All right, I'm going to go over this review in preparation for your upcoming test. Now, I know some of these problems might take kind of a long time, right? But that's not every single problem, right? So just for reference, this review has, I think, 18 questions. I think we can skip one of them, so let's say 17, right? Let's just see how long this video takes, right? Just for reference, you'll have a class period, right? So about 48 or so minutes to solve 14 problems, all right? So while some of them might take longer than others, right, some of them should be super quick, right? So like these polynomial equations in the beginning shouldn't really be super long, right? So let's start with 81, all right? So polynomial equations, we want to factor, if we can factor it, or use substitution, all right? So looking at 81, you always want to check if it can be factored, right? And this one can be factored, right? I can take out an x to the third, and I'm left with a 5x minus 12 equals 0, right? And then I can set each of my factors equal to 0, so I'm going to have an x to the third equals 0, 5x minus 12 equals 0, right? And to get rid of this cube root, I can cube it. I'm sorry, opposite of that, right? To get rid of this cube, I can cube root. And so I get x equals 0 as one of my answers. And then over here, I can add 12 on both sides. And then I get 5x equals 12. And so I get x equals 12 over 5, right, as my other answer. Right, now you guys might be thinking, well, where are the other answers, right? So some of you remembered that I said in class, the highest exponent kind of tells you how many solutions you should get, right? And we only have 2 answers here. Well, 3 of them were 0, right? Because if I have x to the third equals 0, really that's the same as x times x times x equals 0. So then this x equals 0, this x equals 0, and this x also equals 0, right? So there's a lot of zeros in this one, right? So 3 of my answers were 0, and 1 of them was 12 over 5, all right? That's kind of one way to think about it, but if you wanted to check your work, right? So it would be something like that, right? So we get 0 and 12 over 5. All right, this next one is another one that we can try to factor, all right? If I see 4 terms, it's already set equal to 0, I can group. So I'm going to group the first 2, and then I'm going to group the second 2, and from the first group, I can take out an x squared. I'm left with an x minus 7. From the second group, I can take out a 4, and I'm left with an x minus 7 as well, equals 0. All right, so let me write this up here. All right, I'm probably going to need a lot of space on the sides for these. All right, so this is going to get us an x squared plus 4, and then an x minus 7 equals 0. All right, so I would set both of these factors equal to 0, so I get x squared plus 4 equals 0, and x minus 7 equals 0. And so one of my answers is 7. And then for my other one, I can subtract 4 on both sides, and I get x squared equals negative 4. Square root both sides, and I get x equals plus minus 2i, right? So we have an imaginary answer here. All right? So then those are our 3 answers, which we were expecting because our highest exponent is 3. All right? So let's try something similar with the next one. All right, so 84 does have a GCF. If you didn't recognize that you could take out the x from the beginning, what you can do is you can group from the beginning as well. All right, so I can group the first 2, and then group the second 2. And then so from my first group, right, again, I'll do this off to the side. From my first group, I can take out a 9x to the third. So I'm going to get a 9x to the third, and then in my parentheses is going to be an x plus 3. From my next group, between negative 4x squared and negative 12x, I can take out a negative 4x. And then I'm left with an x plus 3 as well. All right? And so because my insides match, I can write 9x to the third minus 4x in one set of parentheses, and then x plus 3 in another, equals 0. All right? And then hopefully now it's more obvious that in this set of parentheses, I can take out an x. And I'm left with a 9x squared minus 4 times x plus 3. All right? And now you could set your factors equal to 0 from now and then get a plus minus answer, or you can keep factoring 9x squared minus 4, right? This is a difference of squares, right? So this is going to get me a 3x plus 2 and then a 3x minus 2. right? And then I still have that x, and I still have that x plus 3 equals 0. So I'm just going to set all of these equal to 0. So x equals 0, 3x plus 2 equals 0, 3x minus 2 equals 0, and then x plus 3 equals 0. All right, so then I already have 0 as one of my answers. For my other one, I would get x equals negative 2/3. For my other one, I would get x equals 2/3, right, positive. And then for my other one, I would just get x equals negative 3. All right, so we get 4 answers, which is what we were expecting, right? Because if you look at the problem, I have my highest exponent as 4. All right. 85 and 86, we can do a substitution, but we're going to skip 85, all right, because that gets you really strange cube answers. All right, so let's skip that. Let's just do 86. All right, now I'm going to write 86. I'm just going to rewrite the problem over here just because I'm running a little low on space. All right, so 86 was x to the 4th minus 13x squared minus 48 equals 0. All right, so now we can do a substitution here, or you can recognize that the middle variable has an exponent that is half of the biggest one. All right, so then we can just factor it like normal, right? Factors of negative 48 that adds a negative 13 are a negative 16 and a positive 3. So instead of x minus 16 and x minus 3, or I'm sorry, x plus 3, right, it would be an x squared minus 16 and x squared plus 3. Another thing that we can do is a substitution, right? So I can let u equal x squared, and then I end up with the u squared minus 13u minus 48, and then we would end up with, we would end up with a u minus 16 and a u plus 3. And then we would just have to back substitute that u, right? If that makes sense to you, you can do it that way, or you can jump straight into it like this. All right, x squared minus 16 factors a little bit more. That's going to become an x plus 4 and an x minus 4. All right, and x squared plus 3 is going to stay the same. All right, now I can set all of these factors equal to 0. So x plus 4 equals 0, x minus 4 equals 0, and x squared plus 3 equals 0. All right, so then I get x equals negative 4. X equals 4, and x squared equals negative 3, right, which you would have to square root both sides. And so I get x equals square root of negative 3 is going to get you I, right? Oh, and I already forgot plus minus, right? Plus minus I square root of 3. So then I get that as 2 answers. This is one of them, and this is another one. All right? All right, so now we're going to start a radical equation. All right, so everything up until now, we didn't have to check our answers just because polynomials, whatever answer you get is going to work, right? And maybe later when we learn about graphing polynomials, you'll see that every answer works. All right, but with radicals, there are restrictions here. I know that radicals can never equal a negative. All right, so these are ones where once we get our final answer, we're going to have to go back and check them. All right, so something like this is going to take kind of a long time, right? These are about as long as you'll spend on any sort of problem on this test, right? No other problem on this test should really take as long as this one will. But this is an important one to know just because, I mean, it looks like maybe it wouldn't be too bad, but you'll see that it's gonna get a little bit tedious, right? So let's first, any radical equation, I want to get the radical by itself. Now, if there are 2 radicals, I can get one of the radicals by itself first and then try to isolate the other one, right? So to do that, I'm going to isolate this first one. I'm going to isolate 2x plus 3, and then I'm going to get rid of the other radical and move it to the other side. So I'm going to end up with the square root of 2x plus 3 equals 2 minus the square root of x minus 2, right? And then now doing this, I can square both sides, right? Because I see that the square root is by itself. And then when I square both sides, the square root and the square are going to cancel out. So I get a 2x plus 3 equals this squared is the same as 2 minus the square root of x minus 2 times 2 minus the square root of x minus 2. All right? So we can go ahead and FOIL this side. All right, first times first is 2 times 2, which is 4. Outer times the outer is 2 times negative the square root of x minus 2. All right, I can't do a whole number with a radical, so it's just going to be minus 2 square root of x minus 2. Inner times the inner is going to be minus 2 square root of x minus 2. And then last times the last, right, negative times negative is positive. And then I get the square root of x minus 2 squared. All right. And then the other side just stayed the same, right, 2x plus 3. All right. And then it looks like on this side I can combine these two radical expressions because they have the same radical. I would just combine the numbers in front. So this is going to get me a 2x plus 3 equals 4 minus 4 square root of x minus 2. And then here the square root and the square are going to cancel out. So I'm going to get a plus x minus 2. Right? And I got that from doing the same thing twice. Right? I was able to square it, and so because the square root and the square cancel out. All right. And now look at this entire equation now, right, from that last step that we did. Right? Notice that there's only one radical in this entire equation now that we got rid of the other one. All right, now I want to get this radical by itself, right? So this is what I want to get by itself. So I'm going to move everything else to the other side. So I'm going to subtract 4, add 2, or you could combine 4 and minus 2 on that side first. It doesn't really matter, right? They're going to end up combining anyway. And then over here, the 4's cancel out, the x's cancel out, the 2's cancel out. And so on the left-hand side, I'm just left with the 2x minus x, which is x. 3 minus 4 is negative 1, plus 2 is positive 1. So I get x plus 1 equals negative 4 square root of x minus 2. All right? So now we're getting closer to getting this one by itself. Let's now divide both sides by negative 4. And then that gets rid of the negative in front of the radical. And then I get an x plus 1 over negative 4 equals the square root of x minus 2. All right, and now I can go ahead and square both sides. So we're seeing a lot of work for this one. All right, so this is going to be x plus 1 squared over negative 4 squared equals the square root and the square cancel out, so x minus 2. All right, and then x plus 1 squared, remember I would write that twice and FOIL it. So this is going to end up being x squared plus 2x plus 1, right, on top. Right, if you need to do that to the side, or if you need to do that in an extra step, you totally can, right? I'm just because now it's a lot of work and writing, right? We're going to save the writing when we can, right? So we're going to get over 16 equals x minus 2, right? Negative 4 squared is 16. And then now I want to get rid of that fraction, and to get rid of that fraction, I'm going to multiply both sides by 16. All right, and then over here I can distribute 16. Over here it cancels out, so I just get x squared plus 2x plus 1 equals, distributing that 16 is going to be a 16x minus 32. All right, and then let's subtract 16x on both sides. I'm going to try to get the radical, I'm sorry, not the radical. I'm going to try to get this equation now set equal to 0. So plus 32. And then minus 16x, right? And so we end up with an x squared minus 14x plus 33 equals 0. I just need factors of 33 that add to negative 14, and that's going to be an x minus 11 and an x minus 3 equals 0. All right, so then setting both of these equal to 0, I get x equals 11 and x equals 3, all right? A lot of work for this one, right? And if I zoom out, you're going to see all that work that we did for this problem. All right, but unfortunately, we're still not done, right? We actually still have to check these answers and make sure that they work, right? So I'm going to do that off to the side over here, right? So I'm going to check. So keep these numbers in mind, right? We got an 11 and a 3. So I'm going to check up here to our original equation, right? So I'm going to check x equals 11. When I do x equals 11, I get the square root of 2 times 11 plus 3, right, plus the square root of 11 minus 2 equals 2. 2 times 11 is 22, and 22 plus 3 is 25. So I get the square root of 25 plus 11 minus 2 is 9. All right, 25 square root of that is 5, plus the square root of 9 is 3. So I get 5 plus 3 equals 2, which is not true, right? I get 8 equals 2. So then I know for sure that 11 is not a valid solution, right? Let's check 3 now. I'm going to plug that into the original. It's going to be the square root of 2 times 3 plus 3 plus the square root of 3 minus 2 equals 2. And then 2 times 3 is 6 plus 3 is 9, so I get the square root of 9 plus the square root of 1. And so I get 3 plus 4. I'm sorry, 3 plus 1, which is 4. All right, not equal to 2. Right, 4 does not equal 2, so that means 3 is also not a valid solution. This one actually has no solution. All right, if you checked both of them and they didn't work, you would get a no solution. All right, so you're probably thinking, all that work for a no solution? Yeah, right? These are about as long as you'll spend on a single problem. All right, I don't think, and you're going to notice in this review, I don't think there's a single problem in here that's going to take as long as a problem that looks like this, right? Other things might be a little tedious, but hopefully not as long as that. All right, so that's 87. And then once again, I'll just keep doing the next one, but off screen, I'm going to write the question down just so that I have room to work it out. All right, so here's 89. Just like our radical equations, I want to get the expression that has the fractional exponent to one side of the equal sign, all right, and then everything else on the other. So what I'm going to do here is I'm going to add 25 to both sides of this equation. It cancels out on the left, and then we're left with an x minus 1 to the 2/3 equals 25. And then now I want to get rid of this fractional exponent, right? So to get rid of this exponent of 2/3, right, we can raise both sides to the reciprocal. The only thing, some people might find it a little confusing because we're going to have a plus minus in this one, right? But to make that a little more obvious, I'm going to show you guys that this is going to become, right? I'm not going to write this every single time, but just so that you guys know, if I have x minus 1 to the 2/3, that's the same as x minus 1 to the 1/3 to the power of 2, right? If I have a power to a power, if I have a power to a power, you can multiply those powers, right? So 1/3 times 2 is 2/3. So then now we can see that there's something on the outside that we can get rid of by a square root, right? And that's the square, right? So I can square root that. So from here, I would square root both sides of this equation just to get rid of this exponent on top, right? The number on top of the 3. And then doing that, we're going to get an x minus 1 to the, now this becomes a 1/3 equals plus or minus 5, right? And that's, hopefully now that makes it a little more clear that there's two answers here, right? When you take the square root of a variable, then you have to put a plus minus, all right? And then now to get rid of this 1/3, right, I can now raise both sides to the power of 3, all right? So I'm going to do that to the left and to the right. And so that's going to cancel out over here, and then I get an x minus 1, right? Now it's freed from the exponent, is going to equal 5 to the 3rd power and negative 5 to the 3rd power, right? So I'm going to write that as two equations. So 5 to the 3rd power, and then x minus 1 equals negative 5 to the 3rd power, all right? And then 5 to the 3rd power is 125, so I get x minus 1 is 125. Add 1 on both sides, and I get x equals 126. All right. And then over here, I get an x minus 1 equals negative 5 to the 3rd power is negative 125. And I can add 1 on both sides, and so I get x equals negative 124. All right, and these are my two answers here. I don't have to check these because I have an odd root, right? So notice that 3 on the bottom. All right, 3 on the bottom is the same as a cube root. So this is the same as the cube root of x minus 1. All right, and then cubes don't really give us any issues, right? I can put any number I want in this cube root, right? So whether it's positive or negative, right? If it was a square root, so let's say it was our original equation had a 3/2 as our exponent, right? That's a square root, and I don't want negatives under a square root, and square roots can't equal a negative, right? So here I don't really have restrictions because the cube root is fine the way it is, right? I can put anything in there. So these are my two answers. All right, so I'll try the same thing with this one. All right, this is our next one, number 90. All right, and then once again, if I have a number on top, I can get rid of that by doing the root of whatever with that number as the index, right? So this cube is the same, this 3 on top is the same as a cube, and I can reverse a cube by cube rooting. So I'm going to take the cube root on both sides. All right, so then I get an x plus 2 to the 1/4 equals, this is just going to be 3, right? There's no plus minus here just because, right, cube roots always give you the answer that you expect, right? I'm allowed to cube root a negative, that would get me a negative number. Cube root of a positive is always going to get you a positive number, right? So there's no plus minus here, all right? And then now to get rid of that 4 on the bottom, I would raise both sides to the 4th power. All right, and then that's going to cancel this here. And so I get an x plus 2 equals 3 to the 4th power is 81. And then I can subtract 2 on both sides, and this is going to get me x equals 79. All right. This was an even root, right? So there was a 4 down here. So we can check it, but we're going to see that it is going to work, right? This is actually a pretty simple check, right? 79 plus 2 is 81, all right? And if I take the 4th root of 81, that's going to get me 3, and if I raise 3 to the 3rd power, that does get me 27, which was on that side of the equation, all right? So x equals 79 is a valid solution. All right, so now let's try 91. All right, this is a rational equation. All right, rational equations also have their restrictions, right? I don't want 0 on the bottom, right? That's something that we would check once we get our answers, but hopefully you remember to solve these kinds of problems, I would need to have a common denominator. Now between x and x plus 2, right, this 1 is going to have a denominator of 1, right? So between these, my common denominator is going to be x and an x plus 2. So then I'll go one by one, and I'm going to see what each thing is missing to get this as a denominator. All right, this x is going to this x is missing the x plus 2, so I'm going to multiply by x plus 2 over here, getting rid of our denominator. All right, this 1 over 1 is missing both of these, so I'm going to multiply the top by x and x plus 2. All right, so equals x and an x plus 2. And then this 3 over x plus 2 has the x plus 2, it's missing the x, so I would just multiply by x. All right. And then now that we got rid of the fraction, we can solve this quadratic equation. All right, so let's try to get it in standard form. I'm going to distribute that 5, distribute the x, and so this gets us a 5x plus 10 equals an x squared plus 2x plus 3. All right, so let's get everything to one side. I'm going to subtract 5x and then subtract 10. All right, and so this is going to leave us with an x squared minus 3x minus 7 equals 0. All right, now this cannot factor. So what we're going to do is we're going to have to either use the quadratic equation, the quadratic formula, or complete the square to solve this problem. All right, I'll use the quadratic formula just because our middle number is odd. So completing the square is going to give us fractions, and we don't really want to deal with that. I would rather just plug it into the quadratic formula. So I'm going to get a equals 1, b equals -3, and c equals -7. So I'm going to do x equals negative b, so -3 plus minus the square root of -3 squared minus 4ac, so minus 4 times 1 times -7 over 2a, so over 2 times 1. And then simplify this as much as we can. I get a 3 plus or minus the square root of 9 plus 28 over 2. And then 9 plus 28 is going to get you 37. So I get 3 plus or minus the square root of 37 over 2. All right? And then our only restriction here is that I can't have 0 on the bottom. But of course, the only things that would make the bottom 0 are if this x was 0 and if this x was negative 2. Obviously, this big radical answer is not going to get you 0 or negative 2, right? So this is a valid solution. All right, so I do have room over here to finish up the rest on this page. Now with absolute value equations, you want the absolute value by itself, and then you want to set two equations equal to the original and the opposite of the original. All right, so here my absolute value bars are by itself, so I'm going to have an x minus 5 equals 10. And then as another equation, I'm going to have x minus 5 equals negative 10. All right, so I can add 5 on both sides, and then I have x equals 15. And then on the other side, I can add 5 on both sides, and I'm going to get an x equals negative 5. All right. Now, our restriction for absolute value equations is that we never want this equal to a negative number, right? Because the absolute value of anything is always going to get you a positive number, all right? So no matter what you plug in here, right, into this equation or into this expression on the left, you're always going to get a positive number, right? So we don't really have to check these two answers, right? Because it's always equal to a positive number, and we did the math correct, so there's really no issue here, right? The only time where we would want to check is something like 95, where I have a variable on the outside, right? Now, when you get your answers here, there is a possibility that if your answer is negative, or even depending on the problem, even if it's not negative, sometimes when you go to plug it back in, you get that it equals a negative number, and thus it doesn't work, all right? So I'll show you what that means for 95. All right, so 95 is already set up for us the way we want it, right? I want the absolute value bars on one side, everything else on the other. So I'm going to set up two equations. I'm going to have an x squared minus 3 equals 2x, and I'm going to have an x squared minus 3 equals negative 2x. All right, so I'll solve both of these, right? I can subtract 2x, and so I get an x squared minus 2x minus 3 equals 0. And then I get an x minus 3, and then an x plus 1 equals 0. All right, so then I get an x equals 3, and then an x equals negative 1. All right, and then doing the other side, I can add 2x. So I have x squared plus 2x minus 3 equals 0. And so I get x minus 3, plus 3, and then x minus 1 equals 0. So then I get x is negative 3 and x equals 1, right? Notice that when I have negative answers, right, these two negative answers, when I go to check them, right, I'll check it here, right? So I'll check, right, the negative numbers are going to give us an issue, right? I'm going to plug it into this side of the equation, and then I'm going to have a 2 times negative 1 equals negative 2, right? And that can't work because I have the absolute value equals something negative, which doesn't make sense. So negative 1 is not going to work. Now, if I check x equals negative 3, that's going to be a 2 times negative 3, which is negative 6. Again, right, I don't want a negative on this side of the equation, right? An absolute value can never equal a negative, so negative 3 does not work. And then when you plug in 3 and 1, you get positive numbers, and you can verify that these do work, all right? So 3 is an answer, and 1 is another answer, right? So one thing to note about this problem is that just because an answer is negative doesn't mean it's a no solution, right? Plug it back in fully and see if you get a negative on the other side of the equation, right? Let's say this was like 2x, I don't know, plus 5, right? If I plug in negative 3, that's still going to get me a negative, but if I plug in negative 1, that gets me a positive. All right, so depending on the problem, it might not be all negative numbers or no solution. It was in this case, but you should always check it and fully simplify the right-hand side of the equation before coming to a conclusion. All right, so then that's this page. All right, so we did a good amount of problems. All right, a lot of work. And we'll do the next page now. All right, so I'm gonna look up here. This is where we start our inequalities, right? Our inequalities, I will say on your test, they're gonna tell you to graph, I'm sorry, not graph, but to write our answers in interval notation. All right, so that was the only thing that was super new with the linear inequalities, right? So something like 103 and 105 should be pretty simple, right? So I'm gonna distribute that 3, and then we're gonna solve for x, right? So then I get a 3x plus 6 plus 7 is less than 2x minus 5. All right, and then this is gonna be a 3x plus 13 is less than 2x minus 5. And now let's subtract 2x, subtract 13. And then so I get, when I fully solve this inequality, it's gonna be x is less than negative 18, all right? So this is your answer as a statement, right? I would sketch a graph just to see where our solutions are gonna be, right? So if I have negative 18, because this is a strict inequality, I'm gonna have an open circle over negative 18, and any number less than negative 18 is gonna be to the left of it, right? So this is where our solutions are gonna be. Now, again, we won't check for these, but if you have these correct, then it's easier to write your answer in interval notation, right? And in interval notation, I would go from negative infinity, right? Because we're going from left to right. And if we have an arrow going in this direction, that means anything on the left is a valid solution. So I would go all the way to negative infinity, and I would end up at negative 18. Because it's an open circle, I would have a parentheses. All right, so this would actually be the final answer, and this is the one that you would circle or box when you get an answer on your test. All right, so we'll do the same thing for 105, right? If you don't like the fraction, you can multiply by the denominator on both sides of the inequality, and that'll just get rid of it, right? 1/2 times 2 goes away, and 2 times 4 over here is gonna get you 8. So I get an 8 times 5 minus 2x is less than or equal to 8 minus x. I can distribute 8, and that's gonna get me a 40 minus 2x is less than or equal to 8 minus x. And then I can add x on both sides, subtract 40 on both sides, and oops, I made a mistake. Okay, this is not 2x, right? 8 times 2x. Sorry, is gonna get you minus 16. Whoa, sorry, minus 16. All right, and then so what we end up with is a negative 15x is less than or equal to negative 32. And then I can divide both sides by a negative 15. Right, remember that dividing by a negative is gonna get you an inequality moving to the other direction, right? So because we divided by a negative 15, this has to flip direction. So this is gonna be x now is greater than or equal, right, to 32 over 15, right? Those negatives cancel out, so it becomes 32 over 15. And then I would graph these. And so I would have a point right here at 32 over 15. All right, and because it's with equality, I'm gonna have a closed circle. Anything bigger than this number is gonna go to the right. All right, so it's gonna be everything over here. All right, let me use a different color actually. So it's gonna be everything over here. All right, and then to write this in interval notation, right, because again, that's how I'm checking your answer. From left to right, it's gonna start at 32 over 15, and because it's a closed circle, I'm gonna have a bracket, and it's gonna go all the way to infinity. All right, so then this would be your final answer. All right, so now with an absolute value inequality, right, we can try something similar to how we did quadratic inequalities, right? When solving absolute value equations, we would do the same thing, right? Split it up into two different equations or inequalities, and then we can pick a test point like how we did with quadratics, right? So I'm gonna have this turn into an x plus 6 equals 5, and then an x plus 6 equals negative 5. All right, so I'm going to subtract 6 on both sides. I get x equals negative 1. Subtract 6 on both sides over here, and I get x equals negative 11. All right, so then I'm going to draw a little number line, right? I'm going to have a negative 11 over here and a negative 1 right here. And I'm going to test a number, right? The easiest one to pick is 0, right? So I'm going to pick 0. And then when I plug 0 into my original inequality, I'm going to have absolute value of 0 plus 6 is less than 5. And so that's going to give us 6 less than 5, which is not true. So this section's not going to work. The middle one will, and the one at the very end won't. All right, so I'm going to shade in between. And because this is a strict inequality, I'm going to have open circles. And then my answer in interval notation is going to be parentheses, negative 11, comma, negative 1, parentheses. All right. Shouldn't be too bad, right? Pretty simple. All right. And then it looks like left over, we have a couple left, right? I have 2 quadratics, or 2 polynomials, and then a rational. All right, so let's try 111. All right, so with quadratic inequalities, I want to get 0 on one side, my polynomial or quadratic on the other. If we can factor it, we will factor it. And so this is going to get me an x minus 9 and an x plus 3. And I'm just going to pretend it was equal 0. All right, and then we have x equals 9, x equals negative 3. And then I would plug this into a graph. All right, so then I get negative 3 over here, 9 right here. The easiest number to test is 0. So I'm going to put 0 right there. And then I get a 0 squared minus 6 times 0 minus 27. Right, 0 cancels these things out, and so I get a negative 27 is less than 0, which is true. Right, so our middle section works, and then our outer ones don't. And because this is a strict inequality, I'm going to have open circles. All right, so then going from left to right, this is going to be negative 3, comma 9 with parentheses. All right, and so now let's try 113. Right, with 113, this isn't a quadratic, but it is a polynomial that we can factor, right? And it looks like I can take out a 5x, and then you're left with an x minus 9, or x squared minus 9, sorry. Just going to pretend it was equal 0. And then we can factor this a little more. I get a 5x, x plus 3, x minus 3 equals 0. And then solving each of these, I get x equals 0, x equals negative 3, and x equals 3. All right, and then I can plot this on a number line. So I get 3 points, right? Negative 3, 0, and 3. All right, now I can't use 0 here because 0 is one of my key points, right? So I would pick the next best thing, which is 1, right? I'm just going to pick 1, and that's going to go in this little interval right here. All right, and I'm going to plug 1 into the original. So I get a 5 times 1 to the third minus 45 times 1, right? So this is going to get me 5 minus 45, which is a negative 40 less than 0, and that is true. All right, so then this interval works. The ones right next to it don't, and then this last one does, right? Remember, these 3 points are going to split it up into 4 parts. And so I'm going to shade everywhere that I have a check. And then again, this is a strict inequality, so I'm going to have open circles. All right, and then going from left to right, my leftmost value that works is going to start all the way to the left, which is at negative infinity. And then that's going to finish at negative 3 with a parentheses because I have another set or another interval. I'm going to write a little u, and then this is going to be from 0 to 3. All right, and then that's our answer in interval notation. All right. And then so we'll finish with these two. All right, so I'll do 115 and 116. All right, so with 115, I'll actually write that to the side over here. All right, so with rational inequalities, I want 0 on one side of the inequality, and then I want a singular fraction on the other. All right, so it looks like we can move this side to the other side. All right, and so this is going to get us 2 over x plus 1 minus 3 over x minus 1. All right, is less than or equal to 0. All right, now I want to get this side under one singular fraction. And it looks like our common denominator between these two, they don't have factors in common, so I'm going to need an x plus 1 and an x minus 1. All right, so it looks like over here I can multiply the top by x minus 1, so I get 2 times x minus 1. I'm going to carry that minus, it's going to be a minus 3. It looks like I need to multiply this by x plus 1. All right, just to get it under a single fraction. Right, and then I can distribute that 2 and distribute that negative 3. So we get a 2x minus 2 minus 3x minus 3 over x plus 1x minus 1 is less than or equal to 0. And then I'm going to combine like terms on top. This is going to get me a negative x minus 5 over x plus 1x minus 1. All right. And then now that I have a single fraction, I'm just going to set the top equal to 0, and I'm going to set the bottom equal to 0. All right, so I get a negative x minus 5 equals 0, and then I get an x plus 1 equals 0, and an x minus 1 equals 0. All right, so this is what's on top. This is what's on the bottom. All right, so it looks like on the top, I'm left with an x equals negative 5. On the bottom, I get an x equals negative 1 and an x equals 1. Right, these aren't our final answers, but we are going to need these to graph our answers on a number line. All right, so I'm going to write this over here. I'm going to have a negative 5, a negative 1, and a 1. Again, easiest number to test, 0. Right, and 0 goes right here between this negative 1 and 1. All right, and I'm going to plug 0 into my original inequality. I get a 2 over 0 plus 1 is less than or equal to 3 over 0 minus 1. And then I get a 2 is less than or equal to negative 3 after simplifying. All right, and this is not a true statement. All right, so I can't have anything negative be greater than a positive. All right, so this middle section does not work. That would mean the 2 sections right beside it do work, and this last one does not, right? Remember, we have 4 sections here. All right, so then I'm going to shade everywhere that I have solutions. One thing I do want to keep in mind is we can't have 0 on the bottom. So even though we look at our original inequality and I have an equal sign, right? I have less than or equal to, all right? That would imply that we would need closed circles, but remember, I can't have closed circles over what makes the bottom 0, because if the bottom is 0, it's undefined, all right? So that means I would need open circles over the 1 and the negative 1. So a negative 1 over here and the 1 right here. This 5 is okay. I can have a 0 on the top. That's just going to make my expression equal to 0. And we are allowed to have it equal to 0 because it has the line underneath. But on the bottom can never be equal to 0. All right, because that's going to make it undefined, right? It doesn't make it 0. It doesn't get you a true statement. It gets you undefined. Right, so then I get this as my answer as a graph. And then in interval notation going from left to right, it's going to be negative 5, comma, negative 1, parentheses, union, 1 with the parentheses, comma, infinity, right, in interval notation. All right, so then you can see the actual work for this one, it wasn't super difficult, right? Really the hardest part, and you can see on the screen, the thing that took the most work was getting everything under a single fraction, but it really shouldn't be taking you super long to do these kinds of problems, right? This is maybe about as complicated as it'll get. All right, and then we're gonna finish up with 1/16. 1/16 is really quick just because we already have a single fraction on this side and we have 0 on this side. All right, so there's really not much more I have to do other than set the top and bottom equal to 0. So when I do x minus 5 equals 0, I get x equals 5. I would need to put that on a graph. And then when I do 3 minus x equals 0, I get x equals 3. All right, so then I would plot those on a number line. And then I would get a 3 and a 5. All right, and then again, we have 3 different sections. I would test the easiest number possible, which is 0. And then 0 is going to be on this side of the graph, right, of our number line. So then I'm going to do 0 minus 5 over 3 minus 0, which is going to get you negative 5 over 3 is less than 0, and that is true, right? So this middle section, the middle section does not work, but the one with the 0 and the one at the end do work. All right, so then these I'm going to shade. And then because this had a strict inequality, I can put open circles over the 3 and the 5. And I don't need to worry about the domain restrictions on the bottom just because this is already a strict inequality, right? We're not including the 3 and the 5 in our answer regardless, right? So I don't need to check if the bottom is going to get you 0, right? Because there was already an open circle there. All right, and so writing our answer in interval notation is going to be from left to right, negative infinity, comma 3, parentheses with a little union, 5, comma infinity with parentheses. All right, and that's your entire review, right? At least one of them, right? This is one of your reviews, and you have a couple more, right? And you can see, I think this video is like 45 minutes, right? And I did 18 problems working through all of them with you guys. Obviously, some of them are going to be a little bit lengthier than others, but hopefully you can see once you study and once you know what to do upon looking at each type of problem, it's really not so bad, right? Especially the ones on this page, right? Took way less time than the ones in the previous page did, right? There was also more problems in the previous page, but again, just take your time with learning the material, but when it comes down to test day, right, you should know what to do when looking at each type of problem, right? So again, inequalities should always be in interval notation. Equations, you should get an actual answer, but then check your answer if it's extraneous if needed, right? You're not always going to have to do it, right? Sometimes you don't have to check at all, and then sometimes you only check in certain cases, all right? But good luck.